Okay, let's move on now to this idea of combining functions, putting functions together. And I know on the screen this is slightly blurry. I apologize for that. I'm not able to focus it any better than this. So look at the handouts that you have in front of you or should have in front of you. What we're going to be looking at here is putting two different functions together. We're going to call them f and g. We could call them whatever, but we tend to be boring in math and call most functions f of x. And then when we need another one, we just go to the next letter of the alphabet, g of x. And we can see here sum, addition, difference, subtraction, product is multiplication, and quotient division. That we're able to take these two functions and put them together just using basic math. So if we have two functions we want to add, we simply take what is in f of x and take what's in g of x and add all the pieces together. For the difference, subtraction, we're simply going to subtract. F minus g says take g away from x. So we're going to simply subtract the terms of g, flip their signs, and combine them with f of x. For the product, fg, notice there's no little dot or anything in there, it's just implying multiplication. We multiply all the terms of f and g. And last but not least, quotient. F divided by g, we have f of x in the numerator, and we put g of x in the denominator. And of course, the caveat here is that g of x can't be equal to 0 because we have an undefined situation. So why? Why would we do something like this? And an example that comes to mind, if we were in the classroom, I'd ask you guys if you had any ideas. But for me, what comes to mind is in a business situation. So say here that you know that the cost of your labor, let's keep it simple here. So your labor cost, say X is the number of units that you sell. So say you're in the business of selling cell phones. And so your labor cost, what you pay people in the store, is going to be L of X. So this is the function for your labor or your payroll cost. And let's say you have another function that you've come up with to come up with the price of your cell phones. So let's call this C of X. So this is the function for cost of the phones. So we're in this business, we're a competitor of, I don't know, Verizon or somebody, and we are in the business of selling cell phones. So we have a store, so we pay people to work in the store, and then we have to pay for the phones that we sell. So if we want to know the cost of business, so let's call this B of X is the cost of business. I mean, obviously there's more cost involved in your business. You have rent and light and all that, but let's just keep it simple that it's just your payroll and the cost of the phones. Well, your cost of business, your B of X, is going to be your L of X plus your C of X. So you could create this third function here, B of X, and say, just take the two functions I already have and add them together. Obviously, there's other scenarios we could come up with, but just to point out, yeah, this is something that would be useful. In a business situation or other situations where you have a number of functions and you are able to combine them so that it gives you one function, one equation that you use to get to the answer you want. Now here, just before we leave this, I'm thinking we have the cost. We could come up with another function here, your profit. Just to show this would be subtraction. So your profit function is going to be, let's call this your sales function, how much money, minus this B of X, this cost of doing business. So your profit is going to be your sales minus your costs. Okay, so just to give you an idea of how this can be used. I think what we're going to find is the algebra, the math for putting the functions is pretty straightforward. What we're going to have to consider also for all of these problems is then the domains of these functions that we have created. So in order to find the domain, and it says here that the domains are going to be common to both f and g, and that's symbolized here as this not union but intersection. So I've written some words of explanation here. Let's take a look at this. After we've created these new functions, either through addition, subtraction, multiplication, or division, the domain are going to be, what we're going to have to do is we're going to have to look at the domains of each function independently. We're going to have to look at the domain of f, and we're going to look at the domain of g. So here, we're going to find the domains of f and g, and then we have to find their intersection. So if some values of x have to be kicked out of f or g, they have to be kicked out of the domain for our final function that we've created. And one final note here, if the function can be simplified, so if we create one of these complex fractions, we're going to determine the domain before we simplify to make sure we have covered everything. So I'm going to stop this video here. I think it's long enough. And then the next two videos we'll get into some examples.